Hi guys. I would say 5 steps back and maybe 1 forward. Last days since the last vlog. This is design vlog number 2. I'm gonna try to keep it short and not too complicated, I hope. If you're interested in Fusion 360 or 3D printing, DIY, then follow along, or yeah, whatever. And so as you see now, the frame looks a little bit different. I would like to have printed parts on this, but you know, not everyone has a printer able to print those big parts. So I decided to let's at least see how it looks like, all framed with the extrusions. So that's what I'm going on. I'm still going with the one front wheel. I know you're skeptical about that, and I don't know. Maybe it don't work, maybe it does. Let's just figure it out. This is a sketch, and I'm thinking out of the box. So yeah, if you did see the last vlog, I had some big issues with Y carriers and placement of idlers and the belt path. Everything was supposed to be very simple, quick, simple, easy to print, of course, a limited amount of support, preferably none. And also, what's important to think about when you are designing for 3D printing, you need to think about alignment and orientational parts. And I've been through a lot of iterations, and I almost gave up on myself. And then I designed something very complex, too many parts, and it worked. I had the tension screw at the bottom. We can have a look at it. As you see, I'm on version 58 now. That just means I saves a lot. Too much, probably. If we go back to iteration number, let's see, yesterday or the day before, yeah, number 49. Let's open iteration number 49 and have a look at that one. So this was something I was playing around with, and it works. I don't like eccentric nuts, eccentric tensioning, and that's why I'm struggling so much, because I mean, it will be very easy to just implement eccentric nuts into this design and just solve it that way. I don't want it. I had it before and it's a terrible solution. It's yeah. So that's why I have the fork on the Viking. Check out the Viking if you didn't. And yeah. So, but anyway, I came up with this idea with sort of something eccentric, but it has these flat spots. So it stops, you know, it has increments of 0.1 millimeter for each flat spot. So the first flat spot is dead on, and if you want a tension of 0.1 millimeter, you can go turn it 30 degrees. And then 30 more degrees, you have 0.2, and then 0.3, and 0.4, and 0.5 if you go over here. That should be more than enough, way too much, but then you have increments, and it could work. I have not tested it, because I just saw that we are getting too many parts, we are getting complicated, we are not easy. We are printing without support. That's nice, but yeah. So I went back to the drawing board and looked at my fork design and thought about, hey, why don't we dig the fork into the wheelbase? because the wheelbase is 10 millimeter. It doesn't need to be, we don't need 10 millimeter for supporting these guys. So I digged 5 millimeter down into, let me take away the fork. So this is how it looks like down here. Let me take away these guys as well. So we are going down into the slider, and we are keeping 5 millimeter in the center here. That should be more than enough. We also have the fork to support everything, and the tension is not that big. So went with M4 here. M3 I think would be a little bit tiny, but M3 and M4 by 8, and then suddenly we are riding very low again, which I like. And now placing those onto the V-slots, guys. Of course, exciting what I did, and we can have a look at how that works out. So here are the guys looking fine, and I have two solutions, one on the A side and another one on the B side. On the A side I go on the inside, on the inner side. On the B side I'm just testing the path on the outer outside of the wheels, and here is inside of the wheels. And if we go outside of the wheels as on the B side, again I'm gonna try to talk about how the belts run for those of you who don't know this stuff. Let me just make this one visible. So this is the pulley, and the belt comes on the outside of the pulley and around and over to this guy, and then over to the X carrier. On the outside, I talked about this last time as well, but just let me repeat it very quick. On the outside we have the belt path just passing through all the way to the corner here and around this guy, and then over to this guy, and then it goes to these guys and over to the X carrier again. So yeah, that's complicated, I know. I'm not gonna mess with that anymore. But what we see, we could go on the outside. That means we are getting, I think, too far out of the frame, because we want to keep this machine compact. And we don't really, if it works out like I have placed it on the A side now, if this work out, we don't lose much build volume. We have the Y, the space for the Y is, well, 180 or 200 something, and on the X we have to stop a little bit before we crash, of course. So I think we will get 190 maybe. Let's say 180. If we get 180 by 180 on this machine, I mean, I think that's good enough for a tiny whiny CoreXY baby. And we also, if building out of extrusion, we need of course some serious angles to support and to connect, and they will also steal some of our build volume. I'm gonna try to maximize this build volume now, just to have a look at what we can do. So I'm going into joints. I'm gonna find this slider joint, which I think is slider number 89, And we can have a look at this one. And we could, oh, sorry, with this fork design, we can actually get more space. We can go maybe all the way over here. Yeah, let's stop there. And the end will then be something, I'm not sure how far out we can go. We might actually get 200 here. It looks like we are closing 200. Then we might get some interference with the hot end and the fans and so yeah, that will be our next challenge. I would like to have the hot end on the front side here. If we call this the front of the printer, we could call this the front and have the hot end here, because it's nice to see the hot end when you have the machine standing in front of you, which I don't do on the Viking. Not a big deal, but yeah. That's for another video, and I think I've talked too much already, but I'm thinking, what do you think? Should we go on the outside of the wheels or on the inside like this? My personal opinion right now, which might change, is to go on the inside of the wheels. We can go, we don't have any, as I can see, any interference whatsoever, and if we have some interference, I will try. I'm sure we can figure it out how to solve that. There is this tension screw which is somewhere, might cause something at this side, but let me look into that in a later stage. So then, if we are going like this, should we have the motors upside down like this, or should I turn them? Should we have the motors downside up or upside down? So that's also something I wonder about. Not decided. I think by going upside down, as you see now, we limit the outer build volume, excuse me, a machine volume, because we can go on top of the extrusions. If we are turning the motor, let me turn this motor once so you can see what I'm talking about. If you flip it like this, then suddenly we have to go down, of course. We have to go further down, something like, yeah, whatever, over here. And then we crash with the extrusions, and then we have to go on the outside of the extrusions. And is that a problem? Really? I'm not sure. Maybe it's not a big deal. It depends on the motor brackets again, because we want to design the motor brackets without any support, and they need to be also printed in a way which gives them strength. When I talk about strength, I'm going to bring out Cura, because when you design parts for printing, you need to think about where do the parts get pulled or pushed or stretched or influenced by forces, you know, and these forks here, they get pulled in the horizontal direction here, and they are actually, you know, they are sitting like this on the machine, so the forces will be vertical at this point. But if we, let's say, if we printed these forks like, let me just place it like this. If we printed this fork like that, we had layers going all up through the fork, and those layers don't have the best adhesion. Of course, they are glued together, but all these layers you see, they are ripping points. They are places which the parts will fail. If the parts fail, it will fail in this layer, between the layers. So that's why we want these parts, or parts which are influenced by forces like this, laying down, printing down like this. Then we have, of course, the lines, the layers are in the same direction as the forces on the part, which is nice. Then we have much more strength in the part. And also these parts, I would like them to be able to be CNC'd easily, and this might be a design something could be CNC'd in aluminum or whatever. We did have to use some support on this guy after integrating the fork into the carrier, but I think we can live with that. Let me know what you think. This is not like a big step since the last vlog. I mean, there's been a lot of work done. You don't see much of it, but yeah, a lot of thinking, a lot of planning, a lot of wondering about what's smart and what to do, make it easy, complex, and so on. So yeah, that's the way it goes when designing something mechanical. That all fits together. So thank you for watching, and happy DIY. Cheers.